Question number 1. Birthday invitations. Alex is printing birthday invitations. An inkjet printer works by having a large number of ink nozzles which spray fine drops of ink onto some paper down here. The ink droplets are charged and pass through an electric field over here, through an electric field that deflects the droplets to their correct position on the page. On the following diagram, draw the electric field between the plates. So electric fields always go from positive to negative. The spacing of the lines is really important, okay, because if there's lots and lots of spaces at one end and not at the other, that would say it's a non-uniform field, but it needs to be uniform. Okay, for the merit, you need to ensure you've got the curvy lines at each end. If they don't have an arrow, okay, they're also incorrect. B, the voltage between the plates is 440 volts. Okay, and the plates are separated by a distance of 0.001 meters. Calculate the electric field between the plates. If we look at the formula sheet on the front page, we're using the first formula, E equals V over D, where the V is the voltage, is the 440 volts, and the distance is 0.001 meters. We can type that directly into the calculator. 440 divided by 0.001, and we get an answer of 440,000. The units for voltage is volts. Units for distance is meters, so we get 440,000 volts per meter. C. The ink droplets have a negative charge. On the following diagram, draw the path of the droplet as it passes through the field. Well, it's going to have a velocity due to the force of gravity, and it's pretty much going to go and hit the plate. Okay, so something like that with an arrow on would give you an A. Okay, a single droplet has a charge of 1.9 times 10 to the minus 10 coulombs. Calculate the number of electrons. It's negatively charged, so we know it's an electron. Pretty much what we have to do is just go negative 1.9 times 10 to the minus 10 and divide that by the charge of a single electron, which you can see over here is on the front cover, 1.6 times 10 to the minus 19. If we head over to the calculator, that gives us an answer of 1.9 e minus 10 divided by negative 1.6 e minus 19 of around that many electrons. Now, I could write out that big number, or I could have a guess at how many numbers it is, and it's about 9, so I'm going to go divide by 1 e9, and in fact it is, the decimal point is right where it needs to be, and so it's actually 1.1, we could call it 9 times 10 to the 9 electrons. Okay, how did I know to divide by this number? Well, think about it. If it has a charge of 1.6 times 10 to the minus 19 of 1 electron, it would just be that one times divided by itself, and it would be 1. And if it was 2 electrons, it would be 3.2 times 10 to the minus 19. And if you divided that by that, you'd get an answer of 2. And so we're just dividing whatever the charge is by the charge on a single electron, and we end up getting 1.19 times 10 to the 9 electrons. So it's a huge amount of electrons. Okay, for E, it says calculate the size of the force experienced by the droplet inside the above electric field. We head over to our formula sheet, and we can see that force equals electric field times charge. The electric field strength from the above question is 440,000, and the charge from up here is negative 1.9 times 10 to the negative 10. Simply type that into our calculator, and we get an answer of 8.36 times 10 to the minus 5. 8.36 times 10 to the minus 5, and the units for force are newtons. We get a negative sign here, which indicates the direction, okay, and so we could say that the direction is to the left, okay, because the force is in fact a vector.